Welcome to the second part of this Build With Me project, where we're going to construct a LED tower that's about 1 meter tall, or not far off it, comprising of about 550 RGB LEDs. And it's all controlled through a microcontroller on this main board. So this is where we're going to start with the actual assembly of this project. In the first part we just unboxed it, had a little look at some of the components. Now we're going to actually get on to making this. So before we do that, what we didn't do in the last one is open up this little bag of components, because I didn't want to lose any of them. But today we're going to have a little look as to what all comes in this. A whole load of SMD chips, another 2, a 40-pin DIP socket, and a little microcontroller. I say little, it's a big one, it's a 40-pin. We have a power amplifier. I take it that's a Class D amplifier, most likely. Infrared receiver, a surface mount 3.5mm headphone jack socket, some assorted hardware, standoffs, sockets, and some LEDs, a little Bluetooth module, some more LEDs, pin headers, more pin headers, and then we've got some surface mount components, power switch, input jack, a couple of short wires, I think these are for the speaker, a little DC to DC converter, some more surface mount capacitors, some surface mount electrolytic capacitors, and there was an assortment of LEDs. So those are all the components, most of which I think are for going onto this board, this circuit board. Now the instructions that are supplied with this are, well, they're translated and not necessarily how I want to proceed, because first of all it says to solder up all these surface mount integrated circuits. I've always been taught and have tried to follow the principle of soldering the smallest components, especially the smallest in height components. And so in this regard, it's going to be these surface mount components first of all. So here we are with a bit more of a macro shot of these small surface mount components. Now very helpfully for the capacitors, they have labelled these as 104 and 105 on the back of these packages, because as you can see there's no text on these capacitors at all. From the top side you wouldn't have a clue which is which. So that's very helpful that they've provided that. And those are the only 2 surface mount capacitors, or 2 values of surface mount capacitors that there is. And they are marked on the board. If we bring the board in, so you can see here we've got C5 105, again C8 105, and up here 105, somewhere, oh there we go, this C3 is 104. So very helpfully they've provided the silkscreen legends as to not just the part number like C6 or R2, but also the value for most of them. So finally we have 2 surface mount diodes. If I just tip these over so that it gets the light at the right angle. It's hard to see through this packaging, but there's a stripe on one end to be able to indicate polarity for this. So we're going to start with these surface mount components. And what we're going to do is start off with just one value, and I'm going to choose this 104 capacitor, and we shall put in all of the 104 marked capacitors on the board. Thankfully, on the circuit board, the small surface mount components are mainly down this one corner. As you can see, there's a few just in that footprint of that integrated circuit, the 40-pin DIP. So yeah, so we're going to start with the 104 capacitors. There's our first one that we're going to do, C3. These are awkward working with such small components. There's a film on the top of this that I'm just trying to get. I'll just have to go off camera, try and pick that off. There we go. So the key with this is not to pull the film all the way off, just enough to release a component. One of the most important pieces of equipment that you could use and need is some flux, just some liquid flux. That makes all the difference. So we get this in position. I have some solder on my soldering iron. And it's just easier to turn the circuit board round, and then we can solder the other. And I'll just reflow this first side just with a little bit of fresh. There we go, that's our first component put in. Let's just see if we've got any other. So I was just hunting around to see if there was any other capacitor locations for the 104 capacitors, and no, it seems that there is only one of those, even though they've supplied 3, and in the parts list they say they supplied 2. The 105 capacitor, they say they've supplied 5. I've got 7. So, and there's only 4 of them on the board. So they give you extras in case you lose some, which would be very easy. These are very tiny components. So now we're going to move on to the 105 capacitors. So, and there we go. Well, I got 2 of them out anyway. There's a couple of locations, so I'll just get a bit of flux. Just the right amount of flux. So that's all the surface mount capacitors. Now let's move on to one of the surface mount resistors. I can't really see what value this is, so let's just have a little look. 101, 100 ohms. 101. So the 100 ohms, there's just one of these on the circuit board. They've supplied us 2.5, very helpful there. This is R6. Dear dear, got it upside down. All the electrons will fall out. Do some more. So what have we got here? 104. This is R1 and R5. So we've got 2 of these. That's all of those surface mount tiny components in place. The only thing left to do with these ones is our diodes, which are down here. stripe, you can see the little arrow pointing towards this pad. And so we have the stripe at that pad. So next up will be actually attaching some of these integrated circuits. So we've got two. So these are ULN 2803AG. If I just check on the parts list, this is for U13 and U14, which are these two positions here. So as you can see, just like any normal dual inline package IC, these have a dot on them. We've got a dot also by pin 1. So we just tack on a couple of leads first of all, just to hold it in position, and then we double check. Yes, we've got our dot by our dot. And what I like to do is just to add a bit more flux. And that really helps you stop getting solder bridges. It also allows you to solder a couple at a time. And because the flux is there, just turned it around there, makes it easier for me to solder. Because you've got the extra flux there, it means you can carry the solder to the pin on the soldering iron, and it doesn't fail the way it would. So now it's just more of the same with the other one. I'm going to pause the video here and carry on and do the rest of all these other surface mount chips, and then we'll come back to you. So something I forgot to record myself doing was actually the soldering on of this Bluetooth board, and also the little power amplifier board which is on the underneath. I'll show you that in a minute. These were quite tricky to do. These are very fine pitch components, and as you can see, there isn't much in the way of a pad on the main circuit board for these to actually attach to. The pad is there, it's just most of it is underneath this module, this Bluetooth module. According to the instructions, you only need certain pins of this actually soldered on, but it was just easier, instead of trying to work at this sort of magnification, to be able to just solder them all rather than trying to count them whenever they're so small. I'll show you the other side of this. There is a slightly bigger pad on this side, but this is a tiny circuit board. Let me get my ruler and I'll bring it in. Those are millimeter graduations, But if you think that's bad enough, wait till you see the other side. I've got this just at an angle because it makes it a little bit easier. See if we can focus it there. Yeah, it makes it a little bit easier to see it. So on this edge of the board we had 4 contacts to be soldered. But when you put the board in place, you cannot see the pads. The pads are exactly the same size as the board. I managed to move it ever so slightly, but if I bring this to upright, there you go. We've probably got a couple of tenths of a millimeter of exposed pad down there. These solder joints, there's a hole in there. It's like a castellated type hole, if I remember rightly, and you just have to solder them and really hope that the solder is wicked through. On this side they are just holes. They weren't castellated. In fact, I don't think they were on the other side. They're just holes, through holes. So this is tricky. This is something that they could definitely improve on. Make larger pads on the main circuit board. It would make it a lot easier. You could even use a wire just to be able to make those joints a bit more sound. But this is only for the amplifier, and to be honest, I'm not going to be that bothered if that little speaker, not even in an enclosure, I'm not bothered if that's not working. I'm not really going to be using this to listen to music through. So hopefully it is soldered up okay, but we will see later on whether it is or not, whether I have to try reflowing this. So before I go any further and add any more components onto this board, I just want to double check that I haven't got any solder bridges. So let's just take a quick look through on these chips, and sometimes you have to angle just to catch the light at different angles just to be able to see is there any little whispers of solder that I just didn't see. And it's always worth just taking the time to do this, because we don't want to really just turn the power on and hope that everything's okay and perhaps spoil our project. So I can see that I've got one just down in there. It may not actually be bridged, but it's very close together. So I'll just get the soldering iron warmed up and get some flux on that, and we'll just see if we can make sure that that is going to be alright. Just the right amount of flux. That seems to have done the trick. So with that done, we can now start on putting these little sockets in. There looks to be about 12 of them, and soldering them in place. As you can see, putting them in place and then trying to correct any solder joints would make things much more difficult. Not impossible, but just making things more difficult for ourselves. So what we're going to do is we're just going to tack one lead in place, and then we can check if the connector is straight and flat to the board, which it seems to be. There we go, that's in place. Not quite as square as I would have liked it, but I'll take a bit more care on the next one. So normally that's quite bad practice to bring the solder to the solder joint, but I'm going to reflow it. Really, it's one of the easiest ways of putting the connector in where you happen to physically hold it and you don't have 14 hands. So you just put the connector on the board, put your finger on the back of it to hold it in place. Get some fresh solder on your soldering iron, a good blob of it, bring it over, and just make a dry, it does make a very dry joint, but it's enough to grip the connector, which then allows you to properly solder it. That's all of those sockets installed. Now we also have some LEDs that actually mount from the underside of the circuit board, as you can see on the silk screen here. They're marked up for polarity with the positive, and I have checked actually that with my diode test function on my multimeter that these LEDs are, with the positive leg being the longer. So we have 4 of these, one in each corner. So we'll just get those popped in. Got to be a little bit more careful with LEDs. You can't put too much heat, especially with them being this close to the circuit board. Just need to let them cool off. Enough in between soldering, just we can also put in these little brass standoffs while we're at this. It'll provide a nice stable base, hopefully. So that is very much nearly that completed for that particular board. So now we come to actually inserting the microcontroller. I've gone over and double checked all my soldering joints. Found a couple actually that I hadn't made, and so did those. And now we want to insert our microcontroller. Now the thing is, with all new dual inline package or DIP chips, whenever you get them, you will find that they are perfectly sized to miss the sockets. The legs are always splayed a little bit too much, and I've already squeezed these in a little bit, but as you can still see, we are still just ever so slightly too wide. You can get special tools for forming these leads back into the exact places they need to be. And what I do is I just use a couple of pieces of wood or plastic, in this case 2 power banks, and you just get them in between the chip in between the two and just give it a squeeze. It just helps to get the legs bent a little bit more accurately. These are still a little bit too wide, so it's a repeated process and you just keep doing it until it's starting to fit. Now, as you can see on the silk screen, we have the legend with the little U-shaped piece indicating the top of the chip, and you might be able to make out there on the chip itself there's also a corresponding one. Just letting you know that that is the top of the chip, and pin 1 well, that's one component broke. I will have to replace that capacitor. The only thing with surface mount components, some of them you only need to sneeze at them the wrong way. Oh, that was just not fully soldered down. That's an easy fix. Just get a little bit of flux. Just the right amount of flux. And while I'm here, I'll just reflow the other end just in case. There we go. So this board ostensibly is complete. There will be a couple of wires to be soldered on for the speaker, I believe. I think it's these two. I've got to go and consult the documentation. Then this board is actually complete. So that's going to be it for this part of the video and the process. Thank you very much for watching along. We hope it's been of some help, and please tune in for the next episode, where we will move on to the next circuit board, which will be like the intermediate board that plugs into this and that everything then gets wired onto. Until then, thanks for watching, and we'll see you next time.